So welcome everybody to the March workshop. My name is Veronica Young. I'm the Senior Program Manager for the Brigade Network here at Code for America. It's great to see a lot of new names on here, and I can't see your face, but hopefully we will meet sometime soon. This is really an opportunity every month for us to be able to talk about various skills that might be relevant to your work, and also provide resources, particularly for our 80+ brigades across the country. So thank you for joining us. We have quite a number of folks in attendance tonight. So sometimes we'll go around and do intros, but I think that would probably eat up quite a bit of our time. So we will have a question and answer portion to the workshop later on, and the device that we'll be using in order for folks to ask questions is the raise hands. So if you're unfamiliar with Zoom, there should be a place where you can raise your hand next to your name, and that's how we'll go through the question and answer portion. But for now, I'm really pleased to welcome Max Hell, who is a senior data scientist with us at Code for America. We're going to be talking about data in preparation for Open Data Day, which is happening in just a few short days. It's also a really exciting month with Code for America Summit coming up just next week in Washington, D.C. So if you have any questions about anything going on in the network, please feel free to reach out to us on Slack or email us at brigade-info@codeforamerica.org. So without any further ado, I will pass things over to Max and let you take it from here.
Great, thank you so much. Can you all hear me? I hope so. Can you see my presentation?
Yes, we can.
Perfect, thanks. So my name is Dr. Maximilian Max. I joined Code for America a couple of months ago. I was doing my PhD at Stanford first. And I am very excited to be able to talk to you about data sources and data science generally, what the kinds of things are that you could and should do in your brigade to spice up your analysis game. So let's get started. The thing that I am most excited about talking about today is a data source that is shamefully underused, and it is called the American Community Survey. It used to be the long-form census, and is now an annual survey. It has a bunch of different questions that you can use, should use, across the whole range of topics that a network might be interested in tackling, right? So there are things on how much income people make, how much educational attainment they have, what languages they speak, their racial identification, where they work, how far they commute, where they migrated from. It's really a rich data source that can answer a ton of questions that you might have about your community, that might allow you to answer more in-depth questions about your city and the kinds of projects that you might be doing anyway, right? And so there are some trade-offs here, right? The big downside of a data set like the American Community Survey, which surveys millions of people every year, is that the questions themselves aren't very detailed. They're not very fine-grained. So in many of the data sets that we like to use for the most precise analysis, we'll have whole batteries of questions on your various income sources, for instance, if you're interested in income. Here, we do not have that, clearly. We're asking questions on millions and millions of people, but in exchange, the samples are huge, as the saying goes, and even more importantly, the samples are representative. So in this day and age of big data, this often gets lost, right? The fact that the American community surveys are representative, which means they let you make claims and statements about the population that lives in your area and the country as a whole. The data in that sense is not biased in a particular direction. That's a really great asset, and that I can't stress enough. So the American Community Survey is really an amazing data set that you really should be using for a whole bunch of different analysis tasks that you might have. It has lots of detail, in particular geographic detail, but also over time. It goes back many, many years. And so this is what we're going to dig into. The problem, though, is that the American Community Surveys are really difficult to access. The Census Bureau makes it very hard. And so they will provide their own tools to analyze the American Community Survey. The problem here is that it's very restrictive. They only let you answer specific questions. The layout is super confusing. It's quite inaccessible. And so the trick really is to forget about the census website. Instead, what we're going to be looking at is a website called IPUMS.org. IPUMS.org is super, super easy to use and to sign up, and it gets funding from the government as well, of course, but is maintained by academics at the University of Minnesota. And IPUMS is really a website that hosts a bunch of different data sets. It's not just the American Community Survey, though the American Community Survey is the best one and you should be using that one first, but it has lots of different data sets as well. For instance, it has the time use survey on how people spend their time. It has a survey that's used to calculate the monthly unemployment rate, the CPS, which is lots of economic data. There's a very detailed geographic shape data in its GIS. And if you want to go crazy, there's also like historical census data, like they surveyed every single individual in the full count census, and that's available from 1940. So really lots of different tools that you can look at. The thing that is distinctive and that you won't find anywhere else is the documentation. And that's really the key to data analysis and data science, I guess, generally, is you have to know what your data, how your data is collected and what your data represents. And what IPUMS has done is it has facilitated looking through the documentation in a way that's really quite revolutionary, and that makes our work as data scientists and data analysts much, much easier. So let's quickly go check it out. Awesome. So here we are at ipums.org. We go to the usa.ipums.org, which is the site for the American Community Survey. We click on Browse and select Data. You'll notice up on the top, I am already signed up. I highly encourage you guys to sign up as well. Of course, that's somewhat up to you, but if you sign up, you can explore along with me. You should only need an email address, and so you can click on things like the household characteristics. So here, I've just clicked on the geographic variables under the household tab here. And so if I click on a variable here, then that variable is added to my cart. I've just clicked on the metropolitan area because I want to know in what metropolitan area the people live in, right? So I click on the thing on the left, and it's added to my cart. I can do this for a bunch of different characteristics and variables that I'm interested in exploring, right? So if I'm interested in, say, find age, I click on age here. Education, which gives me the highest educational attainment of a person in the sample. And so I can click through these variables in a pretty easy way, right? We can spend a little bit of time to just go over the kinds of variables that they have. But if I click on race, for instance, let me add the Hispanic origin and the racial identification of the person surveyed. Right, they have things about the place of work and the commute time, which I can add. So this is the travel time to work that I'm adding. And so once I'm happy with the variables that I'm adding to my analysis, I then go and select my samples on the left. So here, I want to click on the most recent ACS, submit my sample selection. And then if I click on View Cart on the right, it'll show me all of the variables that I've clicked on: age, race, Hispanic origin, education, travel time it takes to work, and then a bunch of other variables that I did not click on at all, but that every time I download a data set, they're pre-selected. So I'm getting them every time, regardless of whether I specified that. And that's basically just to make sure that I know exactly the data set that I have. So you'll notice that year is, for instance, always pre-specified, but also things like the sampling weights for people. So pretty normal stuff. And then you can just click on Create Data Extract. You have the option to specify the format that you want. I'm quite happy with the CSV. And then I can have the variables, displayed again. This extract would be about 340 megabytes, which seems fine. I click on Submit Extract, and then I have to wait a little bit for this to process. And at the end, I can just download it here. Fortunately, I have already done that, so we can keep going with the analysis. So let's continue with the analysis of commute times across the United States by looking at the variables that we were clicking on just now. So for instance, time, right? The variable is just a number, the number of minutes, the time it takes people to get to work from where they live. The mode of transportation is also available, and the variable trend work at the highest year of schooling a person has completed in edu, and then the metropolitan area a person lives in, as well as race. Now, I'm not sure why the images are not loading. One second. Sorry, my presentation is not loading. I'm not sure. you can see the images on the left, but not on the main frame, which is I tried to click present, but that did not work. So I'm not sure what needs to be done at this point. This is very frustrating. I'm sorry. This is a little disappointing. Let's see if we can get. Well, seems like you should be able to see the next one, right? No. Yeah. Yeah, that's a good idea. I'll try downloading it as a PDF. All right, here we go. So if we keep going with our analysis, sorry for the slowdown, we can see, for instance, the distribution of commute times depending on the metro area that you're in, right? And we can even display that by the mode of transport that you're commuting by. So I sort of picked a topic at random that I thought might be of interest to people in different areas. So bear with me if commuting times is not the passion of your heart. We're just walking through an analysis example here, right? So this basically just shows the number of people who commuted for various amounts of time in the different metro areas. And we can already see some pretty interesting patterns, right? So for people who are taking public transportation in Las Vegas, they're taking way longer than people who commute by car, right? That's a huge difference. That's a half an hour in each direction or so, just looking at it visually, right? Which is a big gap. But then if you look at, say, Durham, North Chapel Hill, the difference is not that big, right? So there seems to be quite a bit of variation by the metropolitan area. So if you happen to be in Las Vegas, well, whether or not you're commuting by car or by public transport makes a big difference. But you know, we can do a little more. So if we explore the Las Vegas pattern further, so say you're really interested in Vegas, so we'll see here, this shows us the distribution of the commute times by your racial identification, right? So for people who self-identify as non-Hispanic Black, as non-Hispanic White, and as Hispanic, which is just the academic convention. It's not because those are the best categories to use. It's just a sort of convention, and dropping the other one for lack of the other categories for lack of sample sizes. But if we see here across the racial categories that are available in the data, we see that there doesn't seem to be that much going on. Although if you look closely, the amount of time it takes white people to commute by public transportation seems to vary a whole lot more than for Black residents in the Las Vegas metropolitan area. So we see like some interesting patterns already in the data, right? Let's see. This is cool. I like this one. So here, this is just for Durham doing a similar analysis, right? But you'll notice that the commute times, the axes have shifted a little bit in the figure, right? So whereas in Las Vegas, there were big differences between cars and public transportation and the amount of time it took, right? Less than 30 minutes for cars, more than 60 minutes in public transportation. Now we're like much closer together. It seems like Durham is Chapel Hill is a much better place to commute, regardless of how you identify racially. So that's kind of cool. Let's keep exploring here. This is the commute times in Portland by racial ID and whether or not you had attained a college degree. And this I kind of like. It's basically the thesis is, well, maybe people who have a college degree are more privileged, and so they would have way shorter commute times, if anything. And like what we see is maybe, but not that much, right? There seems to be just like two big lumpings in commute times around 25 minutes and 45 minutes, maybe. It doesn't seem to vary that much by whether or not you have a college degree. So that's kind of reassuring. The last one in this sort of set of in the set of examples that I wanted to quickly show you is the trend over time, right? Because the ACS is fielded every year, you can do these trend analyses. So here in the communities that we were just looking at, right? So we can take a look at the average commute time by whether or not you attained a college degree and how that's shifted over time. And it looks like there's somewhat as we would expect, right? The commute times for people who don't have a college degree seem to be consistently higher, right? But not much of a trend in the difference between college and non-college education. So regardless of the appeal of the commuting analysis per se, one of the things that I wanted to highlight here is that you can explore many different questions pretty easily, right? You only have to do like a few clicks to download the data, and then you can like very easily get them into R and start analyzing. I think the other thing that I wanted to highlight is the kind of sort of quick graphical analysis that I was just showing you. I find super useful. It's the way to explore data, but just punching out graph after graph after graph. So this is one of the things I would highly encourage you to do when you're setting out on your own analysis project is just graph after graph after graph. You can get a feel for the data that way quite quickly. But of course, you can also do fancier things with IPUMS. IPUMS is an amazing tool that has so much information that it gets you from, you know, simple, quick analyses to PhD dissertation. This is from my own PhD, and it shows the share of children earning more than their parents by race, and it uses exclusively IPUMS data. So this is all publicly available data that you can download yourself on IPUMS real quick. And the analysis is a little more involved than for what I showed you earlier. That's why they gave me a PhD degree. But it's super interesting because you can actually see there's this big shift in the share of children earning more than their parents, right? And it doesn't seem to, there's a big decline, as you can see, and that decline is present for both white children and Black children, which is quite interesting. It is even more severe for Black children. So you can do very basic, but also analyses that are really quite involved with this data source. And I think yeah, you should be exploring it in your brigades locally, just to have a few last things, a few like data science things to keep in mind when you do. Usually, it pays off to do a simpler analysis, right? The more complex the analysis, the more likely it is to be wrong. So simple is great, right? Here I'm just like graphing means and distributions. So simple is the way to go. I would encourage each and everyone who's doing data analysis work, if it's in R or in Python or whatever, is to use comments way more than you think is useful or necessary, because 6 months later you forget everything. And yeah, the comments, you need the comments. I also think it's a great idea if you have the time, is to audit each data manipulation that you're doing. So have someone else go over all of the steps. And then of course, wherever possible, try and randomize and do an experiment. But of course, that's not always available, right? Yeah, those are some of the data science principles that I wanted to highlight, but the main thing to keep in mind is IPUMS, go IPUMS. It's the data source that you should be using. It has all of the information that you'd like. My email is hello@codeforamerica.org, so feel free to reach out if you like later on think of a burning question. Yeah. But otherwise, I think I'm about done with what I wanted to sort of walk you through. So if there are yeah, questions or things that cross your mind throughout the presentation, feel free to raise your hand, as you know, as they say.
Awesome. Thank you so much, Max. This was really informative. We'll move on to the question and answer portion of the presentation. So there's a few ways to do this. The raise your hand function is always available if you'd like to ask a question. There's also like a question and answer area where you can ask questions. And then of course there's the chat. So one question that Gracia asked, and I hope I'm pronouncing that right, your name right, Gracia, is that there's so many different account types. Did you get a guest account? Do you know, Max, what the best type of account to get is?
I don't think it matters. I signed up for the like normal one, but I'm not sure. I think I would just go with whichever gives you the like most permanent access. But it's for free anyway. Like you're not going to pay either way. So yeah.
Awesome. And Pam will also ask a question about that. Pam, it's definitely fine to affiliate with CFA or your brigade, but it seems like from what Max is saying that it's a free account regardless. So feel free to use whatever you think is best. We also got a question from Kui, which is, what is UGE and how do you ensure that your data set is representative?
Oh, sorry, UGE just was a joke. The samples are huge. They're very big. Yeah, that's all I meant. Huge. Yeah.
And how do you ensure that your data set is representative?
So fortunately, we as analysts don't have to do that. The representativeness of your data is assured when the data is collected. So the Census Bureau goes out and surveys, you know, hundreds of thousands, millions of people, and they, in picking who to survey and then adjusting those answers, adjusting the answers depending on how many people in each category they get, they assure the representativeness of the data. So unlike private companies collecting data on their users, the Census Bureau that way can guarantee that their data is nationally representative of the whole population. Yeah. So by representative, basically we can understand, like in practice, what that means is that you get a set of sampling weights that you use to adjust the estimates that you get, the averages or whatever, that you're estimating. So you adjust it a little bit so that it's representative of the population at large. So yeah, but that's a great question.
Awesome. The next question comes from David, and it is, how small or detailed geographically does ACS get?
This is putting the finger right in the sore spot. So it used to be super detailed, where you could get tract level things, but they're adjusting this because of the differential privacy rules that are being put in place. So it doesn't look like you can get the same level of detail anymore. The public use areas that they have on IPUMS, I believe at this point are around 100,000 people. So that's sort of so you have like the metropolitan area, and then below that there's what they call the PUMA, and that's like the public use micro area, and it's like 100,000 people thereabouts. You used to get much finer, but recently that was changed. So unfortunately, we don't have quite as much usness in that sense anymore, but we still have pretty good data. It's still like way better than anything else. So yeah, that's sort of how I think about it.
Great. We have a question from Quinn in terms of, have you found any limitations, challenges, cons, etc. to using IPUMS?
So IPUMS itself hosts the data, right? So they get the data from the Census Bureau. The Census Bureau is the one that collects the data, that does all of the data transformation, and then IPUMS only makes sure that the variable names are consistent and the documentation is consistent, and that kind of. So it's much easier to use through IPUMS, but it's not like you're not losing information by going through IPUMS rather than Census. It's just way easier that way. The thing I will say is, if you're very set on the most recent economic data, then IPUMS can have a lag because it takes them a little bit of time to clean the data, so to speak. So sometimes so in certain situations, the Census Bureau is a few months faster, but this should not affect you or me really. It's not, yeah. You shouldn't be trading on that kind of information on your stock portfolio anyway. So yeah, I think that time downside is somewhat negligible in that sense. So I think there are no big downsides. No, I think there are no downsides whatsoever.
Awesome. So Marnie asks, in your tips at the end, you mentioned randomized. Can you say more?
Sure. What I've sort of been talking about is observational data, right? Observational data is data that's already collected, and we have these large-scale surveys, as seen on IPUMS, that let us do analyses after the fact. Right? We can do these analyses where we have a hypothesis and we think well, maybe education and how long it takes you to get to work is related. Let's see if we can see a pattern there, right? That kind of thing. I don't know. I think in many instances, that kind of observational analysis where you're looking for patterns in the data isn't really good enough, because instead what you're interested in is in a causal relationship and saying my education causes me to have, you know, like a lower commute time, whatever. And in that, if that's the analysis that you're really interested in, causal analysis, where you really need to know the cause and effect, which often in medicine, that kind of thing, then we need to make sure as analysts that we know how it was decided, whether or not someone is getting an intervention. So in this case, you know, in the toy example that I was using, it's education, right? So that would be the intervention, the thing that we are interested in, whether it has a causal effect. In the experiment, what it allows you to do, it allows you to randomize so that you as an analyst have full control over who gets the intervention and who doesn't. And that way you can be sure that only the thing that you're interested in, only the intervention differs between the two groups. It makes you much, much more confident in your causal claim, in the claim that education causes lower commute times, whatever. If you don't have full control over who gets the intervention and who doesn't, who gets education and who doesn't, then you can't be confident that the intervention itself caused what you're interested in, or something else entirely, right? Maybe it was that people who, you know, are otherwise interested in whatever have more or less education, and that selection is what's driving the result. So that's why randomization is important. It lets you have full control over who gets the intervention and who doesn't, and that way you can be sure that the intervention is doing what you think it's doing. Yeah, does that clarify it? It's sort of a quick and dirty answer. Yeah.
Marnie, you can answer in the chat or in the questionnaire again. Thanks, Max. Next question is, from Josh. This was similar to the other location question in terms of how does the location data work? It's separate from, it looks like NHGIS is separate from the one shown in the example. Is it possible to get GIS data from the data you showed?
That's right. So in ACS basically asks people a bunch of things about themselves, right? Like, how much education do you have as a survey respondent to the American Community Survey? How much income do you have? How long does it take you to get to work? And then the NHGIS is about geographies. So it includes all of the shape files that have changed over time for like counties, right? So if you need to know like where was LA County in 1970, that's where you go. So it's a little, so the use case is a little different. But it's a good question. And so all of the things that are available on IPUMS, the ACS, CPS, ATUS, NHGIS, they're all available for free. So you can all use those once you've signed up. So that, but if you're interested in like GIS kind of thing, like mapping, then I would definitely check that out. It's very cool. Yeah.
Tim asked, do you have any templates or open source code base for various types of analysis that CFA can make available for brigades to use in our community?
Yes, we have. Actually, so I was going to say yes, of course, and then I realized kind of. So we will make some code available for like what I showed you, which, you know, is like you download the data set and then you like unzip the file and then you like filter down to what you need, right? So we will share that code after my boss has a look at it, and we make sure there's no bugs in it, because, you know, one of the principles of data science is audit each manipulation. But I don't have like a full sort of monster toolkit of like every analysis you could possibly think of. But there's there's a lot of open source stuff already out there. If you have like specific questions, like specific analyses that you're doing, I'm happy to sort of brainstorm and troubleshoot. But yeah, we'll definitely make the code available for the things I sent around. I showed, yeah.
Great, thanks. Key, I believe that we kind of just went through this. They asked, can you explain your data science to randomize? Do you have anything else to add to that, Max?
Yeah, I guess I can talk a little bit about what, how this applies to our work at CFA nationally. One of the things that we're doing here is the Get CalFresh food stamp application in California. And so one of the things that we were seeing in the food stamp application was people weren't making their interviews. They have to interview before they get food stamps with a caseworker, and they weren't going to the interviews. And so the question is like, can we figure out a way of making people show up to the interviews more consistently? And the only way that you can conclusively determine whether or not what you think actually works is by randomly showing some of your applicants one thing and randomly showing some of the applicants an entirely different thing, and then you can use those two populations to compare whether or not they're making it to the interview actually different. And so that kind of randomization is the key to knowing that it was only the intervention, only the thing that you changed, only that one thing that you altered, that was the source of the treatment difference.
Awesome. Just reading this comment in the chat. Okay, Tim says, would love to discuss further about Brigade projects and how to leverage data more effectively, especially local residents engaging with it on their own terms. We just worked with county partners to launch a new open data portal, but there's a question mark around what to do with it. Most valuable template, in my opinion, would be for a community dashboard that can show a few common data points. And Tim will reach out. That's great.
Yeah.
Does anybody else have any further questions that they'd like to ask while we still have Max's time? I'll give it one more minute.
Sure.
We have a raised hand from Tim. Tim, I will let you talk.
Oh, cool. I just wanted to kind of see if we could actually have audio, but also contextualize my question and maybe even go further. One thing that the organization that helped our county create a new open data portal, which is called STAY, was really adamant about wanting to see our universal open data standards that would apply and help us know what to expect when we work with data sets, whether they're from one county or another, which could really help us in the Brigade network. And I wanted to know if you had any opinions on like how we can advocate for that sort of uniformity with our government partners who might have open data but not do much management of it.
Mm-hmm. Yeah, that sounds almost like a program question about how to effectively work with government rather than, or advocate with government rather than a data science person. So perhaps we can most efficiently resolve this by email with CCing the relevant people. So I have thoughts, but I feel like there are people at Code for America who are really qualified to answer this, and I'm not really one of them. And so I think the program people should answer that, not the data science people, right? The people who are in charge of advocating with government. So yeah.
Cool, thank you. Chris asks, are there any runner-up public data sources that you could use if IPUMS did not exist?
If IPUMS did not exist, life would be sad indeed. Are there? Well, so Fred is pretty good, but that's more economic data. In terms of demographic data about your community, IPUMS is a good source. Yeah, I think that, yeah. I think, and then depending on, yeah, no, let's go with IPUMS. Yeah, there's no alternative.
Great, Chris says thanks. Okie doke. Well, if there are no more questions, we can wrap up and give a few minutes back. So if you have anything else to ask, just type it quickly right now while we wrap up, but want to give a big thank you, Max, for your time, for preparing this presentation and for walking us through it. I definitely learned a lot, and it seems like a lot of other folks did too. So this was great. We have recorded the presentation. I posted in the Slack thread the discourse post for this workshop, so we will post the video there, and then Max, I'm sure you'll be able to share the slides in there as well. Okay, perfect. So we'll share the slides in there as well, and then as we work on being able to help create a data set that's easily usable for your own communities, we can update that in there as well. So thank you all so much. Thank you for all your comments and questions, and we will talk to you soon. All right, thanks. Bye.